Lesson 6 in Module 5 is on graphs of linear equations and rate of change. So basically in this lesson, we just want to get a deeper understanding of what it means to be a linear function, calling back some of the things we've done in the past. So what does it mean? Well, first of all, let's start with this rate of change here. We've dealt with rate of change for a while now. And remember, rate of change, well, this basically means, we have a constant. Okay, so that's one of the things. Another word for rate of change is constant. We learned back constant in 7th grade when we're talking about what number are we multiplying by each time. Is it the same? If it is, then we know that the equation at that point was proportional, as long as it went through 0, 0 as well. Another word, more of an 8th grade word for this is now slope. So this is what we're going to focus on today is we're going to be needing to find the slope. But when we find slope or we find a constant, we're finding the rate of change. Same thing with unit rate. Things are happening. We want to know a per 1, and that's the same thing as slope, where, how much is the line going up or down per 1, every 1 unit you move over? What constant are you multiplying by? Okay, so that's the stuff, in other words, for rate of change. For linear equations here, or linear functions, I should say, remember, these are raised to the first power. How do we know something is linear? Well, if its variables are to the first power. If we were to graph a linear function, it's going to be a straight line. Okay, we've been dealing with that a lot. All different types of equations, functions, we've been graphing. If it's a straight line, we know it's linear line. And if it's a straight line, then we know that it has a slope or a constant. We know there is, if it's increasing by the same rate every time, every one you go over, it's going up or down the same amount every time you go over, we know there's that constant, there's that number you're multiplying by. And dealing with slope-intercept form and everything, we call that number the slope. So to be a linear function, okay, that rate of change has to be the same through different points. So if we find the rate of change through a bunch of different points, as we're going to be doing here, and it's the same, then we can say that it's a linear function. Okay, it's kind of going to be similar to finding constants back in 7th grade. So a function is said to be linear if the rule, remember that's y equals something x, maybe plus something else, defining the function can be described by a linear equation. Okay, and actually maybe I'll write down this rule. It's kind of slope-intercept form, right? Mx plus b. Sometimes that plus b is plus 0, but that's okay. Functions 1, 2, and 3 have table values as shown. Which of the functions appears to be linear and justify our answers? Okay, so if we want to know something's linear, we need to find the slope. And what we're going to be using for the slope is slope formula. Hopefully you remember that. If not, I'm going to write it down again. Okay, so we're going to be using our slope formula, the difference in our y's, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we're going to be doing this a lot, so leave some room here, okay? You'll notice I gave you a blank piece of paper here at the bottom. All right, so when we talk about these tables, remember, the inputs are x values, the outputs are y values. And when we write it like that, remember then we get ordered pairs. This is the ordered pair 2, 5. This is the ordered pair 4, 7, and 5, 8, and 8, 11. Now you don't have to write those all out, but you need to recognize that they're ordered pairs. If you recognize they're ordered pairs, then we know we can find the slope. We can put it in the slope formula. And remember, the first one listed is the x, the second one listed is the y's. Okay, so let's pick we have to pick basically a whole bunch of different pairs. So let's start with 2/5 and 4/7. We got to make sure that the slope between them is the same. So I'm going to start with 2/5 and 4/7. X sub 1, x, y sub 1, x sub 2, y sub 2. Write that a little better. Now remember, it doesn't matter which one you pick to be your first point and second point, but both the x and y have to be sub 1s, both the x and y have to be sub 2s. Now all we do is fill it into this formula here. My slope equals y sub 2, 7, minus y sub 1, 5, over x sub 2, 4, minus x sub 1, 2. 7 minus 2 is 2. 4 minus 2 is 2. 2 divided by 2 is 1. All right, then you do the next 2 points. We're going to do 4, 7, and 5, 8. X sub 1, y sub 1, x sub 2, y sub 2. I'm just making them first point, second point because it's easy. Or easier, I should say. Difference in our y's here, right? So I'm going to go 8 minus 7 over 5 minus 4. Well, that's 1 over 1, which is just 1. Let's keep going. Now I'm going to do 5, 8, 2, 8, 11. The ordered pair 5, 8, x value, x sub 1, y sub 1, and 8, 11. X sub 1, y sub 1. Nope, x sub 2, y sub 2. And again, difference in the y's, 11 minus 8, over difference in the x's, 8 minus 5. Well, 11 minus 8 is 3, 8 minus 5 is 3, 3 divided by 3 is 1. Okay, so it's really starting to look here like it is being linear. Let's see, what did I miss? I think I missed one. 2, 5, 4, 7, 4, 7, 5, 8. Oh no, I didn't. Okay, good. So from that case, if we're going from, each point we're moving over, right? Because the inputs are going up. We're going from 2 to 4 to 5 to 8. It's increasing by the same rate. Our rate of change, our constant, our slope is 1. Since it's the same, we can say that this function is linear. Okay? Because remember, they all have to be the same for it to be linear. So, function number 1, linear. Let's do function number 2. Now, I'm not going to write out all the ordered pairs, but if you need to, feel free. Okay, I'll write them down here. So we're going to take y sub 2 minus y sub 1, difference in our y's, over a difference in our x's. Now remember, when we're talking about slope, it's rise over run. We always say that, rise over run. So that's why our y value, right? Our y values are up and down movement. Our x values are left to right movement. So let's start with 2, 4, and 3, 9. And again, I'm just x sub 1, y sub 1, x sub 2, y sub 2. You don't have to make it. You can make this x sub 1, y sub 1, this x sub 2, y sub 2. Doesn't matter. I just tend to kind of go in order. So then to find my slope, difference in my y's. So I'm going to go 9 minus 4. Sorry, don't do that. How about we go 9 minus 4 over 3 minus 2. 9 minus 4 is 5. 3 minus 2 is 1. So that just works out to be 5. Okay, so let's do the next 2 points. Now I'm going to do, I did from 2, 4 to 3, 9. So I'll do 3, 9, 2, 4, 16. X sub 1, y sub 1, x sub 2, y sub 2. Okay, and then just put that in our formula here. Difference in our y's, 16 minus 9 over 4 minus 3. 16 minus 9 is 7. We get 7 over 1, which equals 7. And I notice right here that they're different rate of change, different slope. So do I need to keep going if there's going to be a different slope? Like if it's increasing by 5 and then increases by 7? No. Like, to be linear, you just can't do that. Now, that doesn't mean it can't happen. It just means it's not a linear function. So we're going to say not linear. That's it. Don't even need to keep going because it doesn't matter. They're different. Let's try one more. Okay, same thing. X's, Y's. M equals the difference in our Y's over the difference in our X's. And so I'm going to do the first point. 0, negative 3, and 1, 1. X sub 1, y sub 1, x sub 2, y sub 2. Can really get confusing, guys, but honestly, the more you write down, the easier it gets. Okay, and then you can see I kind of always look. I know I'm subtracting my y's here, so I'm going to go 1 minus a negative 3. I'm going to be careful about that because I'm subtracting 1 minus a negative 3. Don't get to not put a negative there because it's minus. And then 1 minus 0. Keep, change, that becomes 4 over 1, which is just 4. And that was going from here to here. So now let's go from 1, 1 to 2, 6. X sub 1, y sub 1, x sub 2, y sub 2. Difference in my y's here, so I'm going to go 6 minus 1 over 2 minus 1. 6 minus 1 is 5, 2 minus 1 is 1, and that's a 5. And that is a different slope. It is a different rate of change. It's not increasing by the same amount, so it's not linear. Okay, so again, we're just diving deeper into what it means to be a function, and in like specifically a linear function in this case. And if it's a linear function, we need to use our slope formula to find the slopes because the slope is our rate of change. And to be linear, you need a constant rate of change.